Hello again, welcome back to CCCS121, Programming 2. Today we begin the next set of slides uh, dealing with abstract classes and interfaces. Today I'm going to talk about abstract classes. Um, may seem very straightforward at first, and it's actually true. Um, After I show you an example, I'll go into the different reasons why we have abstract classes in the first place. Kind of nitty-gritty reasons, so pay attention to this one. Um, Lots of detailed issues that you need to know about for this. Abstract classes are basically superclasses. Superclasses always has to have a subclass. So if you have an abstract class, if you define any class, an abstract class, it means that you have that class must have, will have a subclass. Now you may, however, uh, uh, what makes a class an abstract class? An abstract class has some methods, just like any of the regular methods that we have seen so far. They have code, you can run them, but an abstract class also can have some methods that contain no code. And I don't mean just a method with no code inside it. I mean uh, really no place to put any code. We'll see that when I get to the example. Now, why might that be useful? I'll talk about that um, a little later. Um, for the moment, uh, just understand that an abstract class can represent an entire category of objects, an entire superclass of classes, category of classes. Um, so, for example, we may have a superclass called living thing. Now, living thing is not an object in the real world. It's a whole category of, well, living things. It contains human beings, dogs, cats, all kinds of animals, plants, even perhaps. And all of these, uh, all of these living things may be doing a lot of the same things. They may be performing a lot of the same functions, which means we may associate the same methods with all of them, such as breathe, eat, sleep, walk. Um, so while all of these methods may be common to all living things, the way these actions are performed may be very different. So, for example, a human being walks very differently from a horse or a dog or a cat. Um, so keep this in mind while I work through the first example. Um, Another very important thing to remember is that if you declare a class as an abstract class, you cannot instantiate it, meaning you cannot create an object of that class. You can create objects of its subclasses, but not of the abstract class itself. So, for example, up here we have an abstract class living thing, um, and if it has two subclasses, human and dog, you could create an object of class human, you could create an object of class dog, but you cannot create an object of class living thing because it is abstract. So for our coding example, I'm going to go back to an example we have now used several times in our video lectures and in class. It is this one, where we have this three-class hierarchy. We have a superclass called geometric object and two subclasses, circle and rectangle. But I'm going to modify. I've slightly changed this example over here. And let me explain what I've changed. And we're going to start off with the code for the original example that we've already written, spent some good time on that. Um, and I'm just going to modify that today to show you how to go from what we had to this example in which we have an abstract class. First of all, let's start with the geometric object class up here. This is an abstract class. But how, looking at just this UML class diagram, how can I tell, how can you tell that this is an abstract class? And you have to pay attention. This is how we can tell. Look at how the way we have written geometric object up here and the way the names of the classes circle and rectangle appear down here. The difference is in the font. If the name of the class appears in italics, that means that that class is an abstract class. So in here that would be geometric object. Um, Another new thing that you'll see over here, see that some of these methods, the constructors for the geometric object class, they don't have a plus sign or a minus sign in front of them. Instead, they have a hash character in front of them. The hash character means that the accessibility, the visibility level of this method is protected. And we already know what it means when we set a method or a variable's visibility level to protected. So this means that these two constructors are going to be protected. Okay. Another thing that's new in this UML class diagram is these two methods. Take a look and probably understand what it is that I'm trying to show you here. The get area and get perimeter method are in italics, slightly um, right-leaning font. Um, this again means that these two methods are abstract. So classes can be abstract, like the geometric object class, and methods can be abstract, like the get area and get perimeter method. You'll notice something else different. In the earlier example in which we had these three classes, get area and get perimeter were methods that showed up that were actually in the circle and rectangle classes list of methods. Not anymore. See that over here. No get area, no get perimeter. No get area, no get perimeter methods. So basically, circle and rectangle both have area, they both have perimeter, but you calculate the implementation of the get area method is different for a circle. You compute the area of a circle using its radius, and for a rectangle using the height and width. So the code works differently. That's why we could not have a shared method up here in the geometric object class. So earlier, that's why we had get area and get perimeter separately showing up in circle and rectangle classes. The same goes for the get perimeter method. Circle and rectangle classes had their own get perimeter methods, and they showed up down here in their UML class diagrams. Now, by declaring these two methods abstract, when we do that, we basically we move up those methods into the superclass, geometric object in this case, and we have to declare them abstract. But remember, like I said, abstract methods do not contain any code. The code for abstract methods actually goes into the subclasses. And this is not optional. The code for an abstract method must be in the subclass, if meaning that the subclass must implement all abstract methods of its superclass. In this case, circle must implement get area and get perimeter. Pretty much everything else is optional. Similarly, rectangle class must implement the getArea and getPerimeter method because rectangle is a subclass of geometricObject, and geometricObject has these two methods as abstract. Okay, so let me also show you something new. So let me begin. Um, the lecture for week 9.2 had these old classes. So first of all, let me start a new project, show you something new and nifty. So it's week 12.2, an empty project. Now I want to use it, start off with the same classes that I had in week 9.2. Since instead of copying and pasting each of these classes, I can do something else. I can select the classes that I want to copy into a different project. So like this, select copy, and I want to move copy these, into project 12.2 into this package week 12.2. So I right click, paste, and select Refactor Copy. Now let me show you what that does. Refactor, and remember over here in the previous project, these classes were part of package 9_2, week 9_2. When I copy them with refactoring into a new project, week 12.2, let me open the geometric class and check up here. The package name has been updated, has been changed to the name of the package where I'm adding this class. Same happened to circle class, same thing to the rectangle class. So that's very convenient. Okay, so like I said, these are still the old classes that we had earlier. Let me modify these now. So first of all, as a class geometric object. First of all, let me make this abstract, and I do that by simply declaring this from just a class to an abstract class. That's one part. The other thing that changed was, jump back here. The other thing was that geometric object, the constructors are now protected. So let me go back here. Let me change these from public to protected. Okay. And finally, the last change to the geometric object class is these two methods, getArea and getPerimeter, which used to be in the circle and rectangle classes. These are now abstract methods of this geometric object superclass. So jump back. So this is public. So it's going to be public method, public abstract method, that will return a double, and the name of the method is getArea, doesn't need an argument. And like I said, this method will not contain any code. So instead of, this does not mean that I write this. This is not how I make an abstract class. Instead, since I've already declared it abstract over here, I don't even put in the curly braces, I just put in a semicolon. That's it. That's how you write an abstract method in an abstract class. And so this is abstract method in an abstract class. By the way, a class has to be declared abstract if it has um, even one abstract method. Okay, and then we had another one, abstract method in an abstract class, and the other one was public. It's also abstract, also returns a double get parameter, and we end it with a semicolon as well. And that's basically it. We have converted, we've gone from the geometric object class we had to making it abstract on the way, making its constructors protected from public, and adding two abstract methods, getArea and perimeter, getPerimeter, and they contain no code because they're abstract. Basically, this is any class that will now be a subclass of geometric object is forced to make these, to implement these two methods. Let's go to the circle. So, circle extends geometric object and already has the getArea method, already has the getPerimeter method. So they're already there. There's nothing we have to change over here. Same goes for the rectangle class. See, we have getArea and getPerimeter, and there are those implementations. So nothing has to change over here. This is the main method for this project. Just run this to make sure we didn't make any typo or anything. Looks like this works. Yes, let me demonstrate something else. I said that it is not possible to create an instance, an object of an abstract class. So let me just show you that geometric object, GO, new geometric object. Okay, so this should throw an error, and it already does. See, geometric object is abstract, cannot be instantiated. So even before you try to compile this, the IDE is already flagging this as an error. Okay, obviously try this. There you go. You get an exception. So I can't do that, but let's see. We have circle C1. Let me make a circle object. There you go, no problem. And guess what? I can do the same thing for rectangle, for the rectangle class. Make that 2, 3, height and width, and compile this. There you go. Again, no problem. I can make instances of the subclasses circle and rectangle, which are subclasses of geometric object, an abstract class. But I cannot make an instance of geometric object anymore because it is an abstract class. Okay, so question. Why do we have abstract methods? What's the advantage of making getArea and getPerimeter abstract? Now, we've already done an in-class assignment in which this actually showed up as a question. We kind of sidestepped it back then to finish to complete the task, but let's talk about it now. The reason is basically that you could not. Uh, so let me first let's make a method equal area for the example that we have, which will compare the areas of two different objects, and it'll be able to accept any type of geometric object. So circle, rectangle, rectangle, circle. You can compare any one with any other. We've done that kind of thing before, so let me just jump back over here. And okay, let's go into the main method. So actually, okay, yeah. So let me show you something new. We make we leave this over here and just begin down here. Okay, demonstration. Use of abstract classes methods. Okay. Um, so let me actually jump in parallel to the main method, and let me first of all let me make a new method. Let's make this one public static because we're in the top level class. It's going to return a boolean. The name of the method is equal area, and this method will work for any type of geometric object and any other type of geometric object. So basically this is supposed to be a method that can compare the areas of any geometric object, so rectangle, circle, 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 rectangle, circle, circle, rectangle, any two types in this case, any two types of objects geometric objects we pass to it, and it returns the value of object1 dot get area, compares it with object 2's area, and if the areas are the same, the return value is true. Otherwise, return value will be false. Okay, so basically going to use this method equal area. So to do that, I'm first going to create two objects. So let's say geometric object over here. This is going to be geo object 1, and this is actually going to be a circle of radius 2, and the other one is, let me call this geoobject 2. Copy pasted this, and the other one is going to be a rectangle with dimensions 5 and 2. Okay, semicolon. Okay, so if I do that, I can now system.out.client. In here, I can simply call equal area and pass it any two objects. I'm going to pass it these two objects, one of which happens to be a circle, the other one a rectangle, and this method will check if these two have the same area. In this case, they don't. run this. And as expected, they don't have the same area, so the return value is false. Just to show you this actually works, I can add a third object over here. I'll make this a rectangle of dimensions 2 and 5. Okay, and then in the next line, I'm going to compare GeoObject 3 and 2. Obviously, these are two rectangles that have the same area. The answer over here should be true, but true. But the point of showing you this is that the first time I used equal area, passing it a circle and a rectangle. The second time I used the same method, but this time I passed it a rectangle and a rectangle. And that is possible because of polymorphism. This equal area method is allowed to accept two geometric objects or any subclasses of geometric object. In this case, circle or rectangle. So I can use the one method to pass it arguments of two different types in 4 different combinations. So instead of writing 4 copies of the same method, I can make one method and it'll work for any combination. And imagine if geometric object had more than 2 subclasses, 3, 4, 5, 6, 7, many more. We'd have so many different combinations in which we could pass it the equal area method to different objects. So using polymorphism, using abstract abstract classes, abstract methods, we can save ourselves that time. And making the get area method that we're calling in here, making sure that the get area method exists for any objects that any geometric object and subclasses that we're passing to the equal area method. To make sure of that, we declared get area abstract, meaning that any subclass must implement this method. Okay. So, just seen the big advantage of having abstract classes and abstract methods. Now, here are a lot of small points that you have to remember. First off, you cannot have abstract methods in a class that is not abstract. Actually, the opposite of a class that is not abstract or non-abstract is also called a concrete class. Now, if a subclass of an abstract superclass does not implement all the abstract methods, the subclass must also remain abstract. So in other words, in a non-abstract subclass extended from an abstract class, all abstract methods must be implemented, like in the example that we did just now. So if you see an abstract method, put an abstract method in any class, that class must be declared abstract. And in a concrete subclass, all abstract methods of the superclass must be implemented. We've tried this out practically. We cannot create an object of an abstract class. We tried that with the geometric object class. We could not create objects of geometric object, but we were able to create objects of circle and rectangle. So that's the other thing. A class that contains an abstract method must be abstract. It's logical, based on what we have studied just now. However, it is possible to define an abstract class that contains no abstract methods. That is allowed. The question is, why? Why would you ever want to do that? Why would you want to declare the class abstract but not have any abstract methods in it? Let's say you have a class somewhere in your class hierarchy uh, that you want to make sure that users cannot create an object of, even though they have no abstract methods. You can do that by simply declaring that class abstract. Declare it abstract, and you cannot create an instance of that class. Instead, uh, an abstract class, even one without abstract methods, will become a superclass to some other subclasses. Okay. A subclass can be abstract, even if its superclass is concrete. So now imagine you have an entire tree of classes, subclasses with more subclasses, um, somewhere in between, starting from the top. So you may have a superclass that's not abstract, a subclass that is abstract. That is perfectly okay. And there's actually an example of that. The object class. Remember, the object class is the superclass of any class that is not extending another class. So geometric object in our case extends object. Remember that. Object is a concrete class. Okay, geometric object, the one that we just made, has been declared abstract, and that's fine. And geometric object subclasses were concrete again. Okay. Um, Another thing, so a subclass can override a method from its superclass and define it abstract. That's okay. So a method that is concrete in the superclass can be made abstract in the subclass. It's very rare, but it is possible. You can do it. It is allowed. Um, Now, like I said, you cannot create an instance of an abstract class, but uh, you can use it as a data type. So for example, uh, this line over here creates an array of 10 geometric objects. Geometric object is abstract. Now, you might say, hey, what are we doing? How is that possible? But remember, this line alone does not create any object. Okay, just creates a list, an array of 10 references to objects of type geometric object. And this line can then be followed up like this. So the first element, geo0, can contain a circle. And the next element, geo1, might contain a rectangle. And that is fine because, again, circle and rectangle are, after all, subclasses of just special types of geometric objects. So this is another use of, um, of having an abstract class, of having a superclass which you cannot create an instance of, an object of, uh, but nevertheless having it. So you could keep different types of objects, circle, rectangle, you could keep them all in a single array if you have to, as long as they share the same superclass, geometric object in this case. So that's it for today. That's all about abstract classes. Next time we'll look at the date class, which also comes with Java, some details to that, and then I think we'll move on to interfaces. So I hope to finish um, the date class, not that important, I think, for us. I hope to finish interfaces and with it this set of lecture slides on Thursday, for our Thursday class.